Hey everyone, I'm Louis. I'm CEO of Mediar, and I've been building AI agents for like 15 years, but back then it was not called like this at all. And I worked in the French CIA, and I'm going to talk about automating Windows legacy systems using deterministic workflows with AI recovery. I like how Kapati, if any of you know him, talks about software 2. So you can think of software 1 as a sequence of logic, like if, else, while statements, while software 2 yourself in the program. And recently we see software 3, where the program can directly control the software. Something I noticed is that there is a missing part of this. The thing is, most of the internet is built with software 1 and software 2. And so AI cannot control the software easily right now. So it's like it's getting exponentially smarter, but it has no hands. And so that's why I was thinking, what if I could give access to AI to the screen? Like the screen is the universal interface, which interact with all the software you use. And so last year, I've built a project called Screenpipe over a weekend and launched on Reddit. And in a few weeks, we reached 10,000 stars on GitHub. We were 2 times #1 trending on GitHub. And someone posted about us on Hacker News, and we were on like the front page, And so we built this open source screen recorder, basically, that would record everything you do on your screen all the time. And a lot of people liked it. It's a bit hard to read, sorry, but in China, they really love like this type of recording software, like Big Brother type software. And just a bit about like the architecture of this project, Screenpipe, screen recorder. It was basically recording the screen and microphone and extracting some metadata out of this and storing on your computer and indexing in a DB. So everything was local first and privacy preserving. On the audio part, so we would record each audio device and do noise reduction, normalization, and other pre-processing like this, voice activity detection, and then speaker identification. So we would create embeddings like vectors that represent like the voice of different person you talk to your day, and also transcribe the audio using like a local model again, typically like the latest version of like distilled whisper model, by taking chunks of the audio, and everything was then stored in the DB. And so it would allow us to, let's say you can get all the conversation you had with John of the past 2 months, for example, and then ask AI, okay, what is the favorite food of John, or anything you want to ask. And on the side of like vision, what we call vision, is we would take screenshot of each monitor and each window in each app. What it means is like imagine you have your browser, and in your browser, each tab is a window. And same in your coding IDE. For example, you have tabs, different tabs, and we extract the text of everything using something called OCR. And typically, operating system have native local models. So Apple and Windows have native model that helps doing OCR. And on Linux, we would use open source models to extract the text. And then everything was stored in this local DB and text. And because OCR is not is not 100% accurate, we also use in parallel something called accessibility API. So if any of you are familiar with HTML, which is like this structured representation of a web page, this accessibility API allows you to get the same similar structured version of your screen, but for everything, including like desktop apps outside of like the web, outside of the browser. And so we would get everything, including the browser, in like structured format and index in the back in the DB. And so we would end up with like a lot of structured data about what people do all the time, everything local again, nothing shared to the cloud. And it would run like four or five AI models all the time, 24/7. And we optimized this pipeline so much it was running on like $200 Windows laptop, and only using 10% CPU and 1 GB of memory. And then everyone had like gigabytes and gigabytes of data on their computer with this. So what do we do with this now? What is useful? So we built, we thought that if we let people just build apps on top of this that use AI to consume this data and share to everyone, it would allow us to find what is actually useful. And so we built something called Pipe Store, which is equivalent of Apple App Store. And people could build Next.js app and publish to the desktop app that everyone was running on their computer. So what we did is that we built some engine that that allowed us to run Next.js app inside of Rust. Like everything we wrote was in Rust, and a bit like Vercel, but for the desktop, if any of you are familiar with Vercel. And people could also like sell apps and get paid for by people that buy the apps. We also did 2 hackathons and 600 participants came. And we had support for like these 3 operating systems: macOS, Linux, and Windows. And there was a lot of demand for a bunch of different features, bunch of different things. It was really hard to find to support everything. And people complained about, okay, this feature is not good enough, or my specific computer is not like this old version of macOS doesn't work. And we use these complaints to find what is like the specific things that people really wanted. And one thing that a lot of people asked for is Windows automation. And so as you see, like this is like the curve of like the star history. We had like this hockey stick curve in October, and then it plateaued like to up to 15,000 stars. And like here you can see clearly it was too hard to maintain everything, and we didn't know exactly what to focus on. And so we we decided to focus down on like Windows automation, and we really originally we really hated Windows. It was like it was so hard to make the software works on all different configuration of Windows. Like there are like millions of different configurations, different computers. While macOS is like everything is it's pretty standard, and so we always fight Windows originally, and now we are like we fell in love with Windows. And something we learned with Screenpipe is after reaching 15,000 stars and 100,000 users, is it's really hard to make a desktop app works well on 3 operating systems reliably. Especially this app was like running like 4 or 5 AI models all the time, recording everything local, really hard. And yeah, it's better to have a few like killer features than many features that are not very good. And last, like the world still run on Windows. Most people use Windows. And so we created this open source library called Terminator, which is was focused on Windows automation. And we leveraged Screenpipe learnings to build it. And so what is Windows automation? So first, you need to understand what you want to automate. And then it should be easy to create an automation, because you often have to do a bunch of this. And it should be fast and reliable, obviously. So some challenges of automating Windows are that you often have to deal with multi-application navigation complexity, like going between like the file system and like spreadsheet or a PDF or some old software. And like you have to deal with very old software with either no API or very bad API. And people, a lot of people are have to do this manual task every day repetitively. It's consuming like billions of hours of people time. And also like companies, another way people solve this is to pay consultants to create automations manually, and every 6 months they need to come back and fix the automation because it's broken. And lately we see people doing like vision-based automation. And but the thing is, how it works is that, okay, you take a screenshot, send to AI, wait 5 seconds, do a click, and then okay, take another screenshot, send to AI, wait 5 seconds, do a click. It's very slow, and like it tells you like the pixel like coordinate where to click, so it's like very unreliable and definitely expensive. So how do you understand what needs to be automated? One way is to use something called workflow mining. So basically, it's recording what people do on their computer. So what we did with Screenpipe, we leveraged what we've built to create a tool that would allow us to record everything people would do on their computer, like typing, clicking, switching apps, everything. And this is like just like a dashboard that we've built on top of this open source workflow recording technology. And as you can see here, I have 300,000 events, 2,000 hours of work recorded on my Windows computer. And we would use this accessibility API again. So it's a very structured version of things that you can see here. Just like example, which is you see like the clicks and the typing, and we would use this to understand what people are doing like repetitively on their computer, and use it for as like context for AI to create automations. And so we have MCP server that like if any of you are not familiar with MCP, it's just like just a protocol to just like AI control the computer, let's say, and so we use it to take the data and some instructions and play around with the computer and try to replace this workflow and improve it, make the workflow faster and more reliable. And we use like YAML syntax to structure it, a bit like if any of you are familiar with GitHub Action, which is like CI/CD workflows. It's similar syntax, like step, click an element, step 2, type, step 3, press a key. And how to make it fast. So we don't use vision by default, and so for vision to like the speed for vision approach is screenshot takes like between 200 milliseconds and like 500 milliseconds, and vision model takes like a few seconds of inference. So it's like a few seconds of every action. Like imagine a few seconds between each click. It's very slow. And our approach is because we compile deterministic workflows, we run at like CPU speed. So it's like 100 times faster. Our approach to measure the reliability, we just have a standard way to know if like the workflow succeed or failed, and we just compute like the success rate as like a percentage. And so this is like some example of workflow we've built, and this one ran 7 times and have 86% success rate for the version 101, and this is like average runtime 6 seconds, while this one is run almost 5,000 times and has a 93% success rate for the version 1066, and the runtime average is 62 seconds. And it's still in preview, but we have this. We work on this feature to have AI leverage understanding of like the specific app and example workflow on this app to recover if the deterministic workflow fails at some point. AI would take over and finish the workflow. So it brings the best of both worlds, both like speed and success rate, high success rate. a bit about what are some like companies in this Windows automation landscape. So the one word used in for Windows automation traditionally is RPA. It means robotic process automation, and some leaders are UiPath, Microsoft Power Automate, or Automation Anywhere, and people often complain that it's brittle and like unreliable, and that their approach is to send you like consultants to implement every single automation, and it takes a lot of time, and every 6 months they have to come back to fix the automation because it's brittle. Other approach are like cloud computer use or Adept previously. And it's like low success rate and slow and expensive. And our approach is to leverage like deterministic compiled workflows with AI recovery to bring high success rate, speed, and speed of deployment. If you are familiar with Playwright, it's web automation software, and we like how they like their developer experience, which allows you to find specific element on the screen using like the hole. For example, you want to find a button, and you can say hole button with the name submit, and then click this, or finding through like the text contained in the element, or other things like this. So we have similar syntax to Playwright. And how it's possible to run in production. So either you run on your device, and it's fast, and no network dependency, or you can run it in a virtual machine in the cloud, Windows virtual machine, to for like scalability. And ourselves, we do run on like Windows cluster, where we have like centralized management and observability. There is an integration with OpenTelemetry to measure like what agents are doing when they fail, and other things like this. So I'm going to show you a demo of how this Windows automation open source library Terminator works. And so here I'm going first to I'm going to record what I do. So here it started. It's recording what I do. So if I type here, you can see there is like a button click and mouse down. And if I say echo, right, and you see it's recording every single keyboard keystroke, and like if I open like Notepad, example, and I close, we can see I switch to this Power Launcher tool, and then I switch back to the terminal and Notepad. And then when you stop, it will save the workflow in a JSON file that you can that contains like all the events you've done on your computer that you can leverage to create automation. And I'm going to show now a very simple automation which opens Notepad and just to open Notepad. Right, yeah. and you can see like the structure of the workflow. It's just like steps like this, and another thing is, so the other day I had an issue with my cursor, and there was a weird like trail behind the cursor, and I didn't know how to fix it. So I opened my terminal and I asked Claude, which just used Terminator MCP to control my computer and fix the issue in like a few seconds. And then I asked to turn it into a workflow. So I'm going to run this workflow. So here it's opening settings and going to accessibility, mouse, and it turned on this. And so that's the issue I had. And I thought my computer was on fire or something like this. But it's just a normal feature of Windows, actually. And if I close it, run it again, and it will just go to do it again, and now it's turn off. And it's a bit hard to read probably, but you can see this is like the tree of the desktop. So I can show you. So this is what I meant by accessibility API, which accessibility API is like it's a text representation of your screen, and we can see with this software allows you to see like this kind of HTML type representation of your screen. That's what we use through the API. Okay. And that's it for the live demo. A few use cases you can build with Terminator. I don't know if any of you are have like parents or grandparents that struggle with using computers or like specific apps or software. Myself, I tried to install ChatGPT on my 90 years old grandfather computer, and it's really hard to use for him. But one use case I think of is in companies where there are people that are either older or use software that is hard to use, is to have an AI IT help desk. So the IT team could help people to troubleshoot their issues or configure some specific settings on their computer with the help of AI. So it could highlight a part of your screen, click things for you, and help you like solve problems faster. Another use case is just moving data between different systems, like for example, like SAP to Salesforce. And we have an example of so it's a command line that allows you to copy paste the content of your screen into your clipboard. So one thing I do personally often is I take a screenshot of part of my screen, and then I put in the AI chat and I ask a question about it so it knows like what I'm doing, has the context. And the advantage of this is that it allows you to get more data than vision. So an example is WhatsApp. If you take a screenshot, it will only see the text visible on the screen. But with accessibility, you can get the full chat history. For example, if you want to help ask AI how to answer your girlfriend, for example. And fourth is just moving, for example, data between files. You have many files to like a spreadsheet, for example, and or just making it easier to use legacy software. For example, old software like myself, I find SAP software really, really hard to use. It's like so hard, and with AI, it would be much easier to use. And just in terms of Terminator roadmap, currently we have Python, JavaScript SDK. We have this workflow recording tool and MCP server to control your computer and create workflows. And in the future, we want to release desktop apps that allows people to create automations easily and test them and publish to the cloud very easily. So the agent can do this automation all the time when you sleep. And we are inspired by apps like Lovable, V0, and apps like this, which are very easy to use. Something else is we want to make it easy to share workflows with other people and embed like workflows inside others. And also, we think the cloud deployment is important to scale automations and run more like testing things in the cloud. And also like the part of recovery to maximize success rate. So this is our this is just a preview of this workflow builder app we are working on. So it would list some workflows you've built and that are running in the cloud currently. And you can create new automation, record a new automation, and it would record everything you do. And then AI learns the workflow and can replay it in front of you. And so you can give it feedback. Okay, is this what I want or not? Give feedback, try again, and fine-tune like the workflow like this. And also being able to run like tests. So think about like you have your workflow and you want to have 10 agents that work on this workflow, like try to make it work. And if something breaks, they work together to improve the workflow. And then deployment to production once like the success rate is like more than 90%, for example. Yeah, it was really great to have the opportunity to talk to all of you, and it would be great to have a star on our repo on GitHub. So it's Terminator, or you can reach out on Mediar.ai platform, or contact me on Twitter. And I don't know if anything in this presentation was missing or not clear. If you have any question.
We have a question in the chat that how do we undo action that the AI takes?
Sorry, can you repeat?
How do we undo actions that the AI takes?
How do we do the action?
How do we undo the actions?
Undo the action? So that's a good question. Right now we are what we think about, we don't have this yet, but we think about implementing in the future like rollback workflows. So it means you would have a workflow to do like specific automation, for example, taking files, creating files and putting in like spreadsheets, and always have a pair workflow that would be used if something fails to like roll back to the action. So like, okay, something failed in the middle, just remove the data from the spreadsheet, and that's what we think of, that we want to build in like next year.
All right. There's another question. How do you handle so much of data, like hours and weeks of recording?
The data processing in the you mean the data processing in the workflow mining, or?
No, I'm talking about in Screenpipe.
How do we handle the so much data?
Yes.
So we just it was just storing like we optimized it a bit, and it was storing like 25 gigabytes of memory per month on your device. And to make it efficient, we had like we would just optimize, just run the program and see how much memory on CPU it uses, and then each like small part of the code you see like avoid doing copies and things, because we had like, it was everything in Rust. You have very fine grained control on like the memory and like optimized CPU also. That's just how we did it. Yeah.
Do you guys have any other question? Yeah. Ahmed, you can go on.
Hello. I came in a little bit late, so I didn't catch everything, but it certainly seems a very powerful tool. In your experience, what are the edge cases or the difficulties where it starts to break?
Yeah, typical difficulties is authentication. So you want to automate some software, and you lose authentication, and so it's important to always make sure that to understand that all the systems are typically they disconnect every day or every specific period of time, and other edge case can be like the environment you run the automation on is important. For example, if you run your if you create your automation on your computer and then deploy it to a virtual machine, like you need to know that the virtual machine is usually it's like much slower than your computer, and for example, it's better to use to avoid using the mouse to click elements, because if the CPU is slow, it can like the mouse can take more time on a slow CPU to reach an element, but you can use like you can actually click elements without using the mouse with the API, with the accessibility API, and that's what we prioritize. So that's some of the edge cases. Then it really depends on like the software.
I see. So it sounds like the clicking via API might be something you end up doing on the back end to speed up for customers.
Yeah, it's much faster than mouse click also, because you don't need to move the mouse. Yeah.
And then with auth, my understanding is the issue isn't filling in and filling in a username and password. It's more so that after you've been doing, the automation for hours, it'll suddenly unplug and then you need to log back in. Being able to recognize and deal with those cases.
Yeah, you yeah, like the idea is to you run ideally you run once you build a workflow, you run it a lot of time, and we collect every single error, and then we have a list of errors, and so the workflow can easily be like all the edge cases can easily be covered.